This is endlessly fascinating to me. Can you describe, first of all, what exactly it is that we are seeing in this image of this black hole?
We physicists have waited 100 years since 1916 for this photograph.
World-renowned physicist Michio Kaku has just revealed a groundbreaking discovery that could completely change how we understand the universe. And it all centers around what truly lies inside a black hole. For decades, scientists have debated whether these cosmic giants destroy everything they consume or hold the key to new dimensions of space and time. But Kaku's latest revelation has stunned the scientific community, suggesting something far more mysterious. So, could black holes actually be gateways to another universe? Today, we uncover his mind-blowing findings. The discovery of a black hole. A black hole, in the simplest terms, is what remains when a gigantic star dies. A remnant so dense, so unimaginably heavy, that its gravity becomes a trap nothing can escape from. Not even light, the fastest thing known to humanity, can break free. That's why it's called a black hole, not because it's dark like the night sky, but because it swallows every trace of light that dares to come close. But how do you study something that cannot be seen? That was the riddle NASA scientists faced. They turned their gaze toward the heart of a distant galaxy known as Messier 87, or M87 for short, a titanic galaxy about 50 million light-years away from Earth. To put that into perspective, if you could travel at the speed of light, 186,000 miles every second, it would still take you 50 million years to reach it. And at the very center of this ancient glowing island of stars, astronomers found something extraordinary, a cosmic storm unlike anything seen before. Peering through powerful radio telescopes linked together across the globe, scientists detected a blazing whirlpool of gas and energy. It wasn't just drifting lazily in space, it was spinning with unimaginable violence, circling the center of M87 at speeds of nearly 1.2 million miles per hour. That's fast enough to go from Earth to the Moon in about 12 minutes. The gas, mostly hydrogen, was heated to millions of degrees, glowing furiously as it spiraled inward like water rushing down a cosmic drain. The question then arose, what could possibly hold such chaos together? With matter moving at such tremendous speeds, logic suggested it should all have flown apart long ago. But something, some invisible power, was pulling it inward, keeping this fiery storm spinning in a tight, perfect circle. To make sense of it, astronomers began calculating. The only way that spinning disk of gas could stay intact was if something unimaginably massive sat at its heart, something with gravity so powerful that it could hold together billions of tons of matter. When they ran the numbers, the answer left them stunned. Whatever lay at the core of M87 had a mass equal to 2 or 3 billion suns. Pause for a moment and think about that. The sun, which gives life to every living thing on Earth, is itself enormous, so large that over 1 million Earths could fit inside it. Now imagine billions of such suns compressed into a single point, not a planet, not a sphere, a point, a place where all that matters collapses into something infinitely dense. That kind of mass doesn't just bend space, it tears a deep well into the very fabric of the universe. Any object, light, matter, or radiation, that crosses a certain invisible boundary around it, called the event horizon, is gone forever. No signal escapes, no information returns. It's as though the laws of physics themselves are swallowed whole. And that, scientists realized, could only mean one thing. They had found a black hole. This discovery didn't just prove a theory, it confirmed one of Einstein's most mysterious predictions from his theory of relativity. For decades, black holes had been a mathematical idea, something that existed only on paper. But here, at the core of M87, was physical evidence of one, a monster silently shaping the galaxy around it. When the Event Horizon Telescope collaboration finally captured the first image of that black hole's shadow, a glowing ring of fire encircling a dark void, humanity saw what had only been imagined for generations. It wasn't just a scientific milestone, it was a glimpse into the heart of cosmic mystery, a place where light itself meets its end and time stands still. In the vast, quiet theatre of the universe, M87's black hole remains a haunting reminder of nature's extremes, a graveyard for stars, a sculptor of galaxies, and a whisper from the edge of reality itself. So, how did the century-long chase begin? Was Michio Kaku the first to identify the mystery? Let's find out. From Einstein's nightmare to the first forbidden snapshot, imagine a secret so dark, so terrifyingly beautiful, that the universe itself tried to hide it for 100 years. It began in 1916, in a quiet study where a wild-haired genius named Albert Einstein scribbled symbols that danced between genius and madness. His equations spoke of invisible giants, creatures born from gravity itself, capable of swallowing stars whole, bending time until it twisted back on itself and devouring even the light that tried to escape. He didn't call them monsters, but that's what they were, mathematical phantoms too strange to be real. For decades, no one dared to believe him. The idea of something so dense that even light couldn't flee seemed like science fiction disguised as math. To many physicists, these black holes were just ghost stories told in chalk, proof of Einstein's brilliance perhaps, but also of nature's sense of irony. Space, they thought, could not possibly hold such darkness. Then, sometime in the 1960s, the universe whispered back. In the constellation of Cygnus, a star the color of sapphire began to scream, not in sound, but in X-rays, invisible light of pure fury. The signals were wild, desperate, as if something enormous and unseen was tearing at it. That something was later named Cygnus X1. What the instruments revealed was staggering. An object 15 times heavier than the Sun, crammed into a space no bigger than a city. It wasn't just heavy, it was hungry, spinning and pulling its companion star into a fatal dance, consuming its glow gulp by gulp. When scientists realized what they were seeing, silence filled the labs. The impossible had become real. Einstein's monster was awake. Gravity wasn't just a force, it was a predator. Cygnus X1 was proof that the universe hid hearts of infinite darkness, places where matter ended and mystery began. It didn't just change astronomy, it changed how humanity saw itself. The discovery sparked a race between curiosity and terror. Telescopes evolved into eyes of metal and glass, stretching their vision across galaxies. Computers began to hum like oracles, learning to decode the whispers of dying stars. And then came the boldest dream of all, to see one. Not in theory, not in equations, but with human eyes. In 2021, that dream became reality. 8 observatories around the world linked together in a feat of global science, a planet-sized telescope built from unity and imagination. For weeks, they stared at the heart of a galaxy called M87, 55 million light-years away, where a monstrous object lurked. What they captured was not a simple image, but a cosmic revelation, a glowing ring of fire encircling a shadow that defied description. The light around it was trapped in eternal orbit, like moths circling a flame they could never touch. At its center lay a perfect absence, a mouth in space where everything, light, matter, time, simply vanished. It wasn't a hole, not really. It was a boundary, a reminder that even the universe has secrets it would rather not share. And as humanity stared into that glowing ring, it became clear. We hadn't just photographed a black hole. We had photographed a warning that the closer we get to understanding creation, the more we must confront the darkness that makes it possible. What does a black hole look like? Are the laws of reality applicable there? Let's delve into the details of the anatomy of what a cosmic trap looks like. 3 layers of doom. Forget the cartoons that show black holes as simple spinning voids that swallow stars. A black hole is far more terrifying and fascinating than that. It's a layered dungeon carved into the very fabric of the universe. It's not an empty space, but a place where the laws of reality twist, fail, and finally collapse into silence. The event horizon is the first layer. Let's think of it as a cosmic velvet rope, the ultimate do-not-cross line, woven entirely from gravity. On one side, light and time still exist. On the other, they vanish forever. The moment anything, a planet, a star, even a beam of light, crosses this invisible border, the universe forgets it ever existed. No sound escapes, no cry for help travels back. Even if you could hover at its edge, the pull would be unbearable. The closer you drift, the slower time itself would crawl until, from the outside, you appear frozen, a ghost paused at the brink of eternity. The second layer is the photon sphere, a glowing, chaotic carnival of light. Here, photons, the particles of light, are trapped in endless orbit. They spin and swirl, chasing themselves in loops that can last forever, creating a shimmering ring. The fiery halo astronomers finally photographed around the black hole in the galaxy M87. Imagine billions of fireflies whirling at impossible speeds, unable to escape, yet too defiant to be swallowed. The result is hauntingly beautiful, a golden halo marking the boundary between existence and oblivion. The third layer is the singularity, the heart of the dungeon, and the end of everything we understand. Deep inside, gravity becomes infinite. Matter loses all meaning. Every atom, every particle, every trace of what once was collapses into a single unimaginable point, smaller than an atom but heavier than a million suns. Here, physics itself dies. Space and time no longer play by the rules. They melt, twist, and disappear. If you could somehow witness it, which you can't, you'd see nothing. Not darkness, not light, just the end of reality as we know it. And if you were ever unlucky enough to fall in, your fate would be one of the strangest deaths in the universe. As you draw near, gravity doesn't just pull, it stretches. Your head feels a stronger tug than your feet. The result? You be stretched thinner and thinner like a strand of spaghetti. Scientists call it spaghettification, until your atoms tear apart and your very identity is erased. You wouldn't even reach the singularity before your body, your mind, and your memory are shredded into nothingness. And yet, for all their horror, black holes are everywhere. They're not rare monsters hiding in distant galaxies. They're common. Astronomers estimate there are more than 100 million black holes in our Milky Way alone, each one silent, invisible, and waiting. The closest we know of sits about 1,500 light-years away, close enough, in cosmic terms, to be a whisper in the dark. It doesn't threaten us, not yet, but its presence is a reminder. Space is not empty, and safety is only an illusion. So forget the cartoon whirlpools. A black hole is not a hole at all. It's a trap of time, a cosmic abyss with layers deeper and stranger than any dungeon ever imagined. And every time we look up at the night sky, dotted with stars, somewhere out there, one of these invisible monsters is quietly watching back, patient, silent, and impossibly close. What are the characteristics of a typical black hole? Who were the geniuses that helped crack these mysteries? Let's dive into the details of the unexpected twist. Spinning rings, hidden tunnels, and the sci-fi twist nobody saw coming. Most black holes spin, and that simple fact changes everything we thought we knew about the universe. In 1963, a quiet mathematician named Roy Kerr cracked open Einstein's equations and found something astonishing. He discovered that when a black hole spins, it doesn't shrink into an infinitely small dot as everyone had assumed. Instead, It stretches and flattens into a whirling ring of fire, a glowing halo of unimaginable energy held open by the sheer force of its rotation. It's a place where gravity and motion are locked in a deadly dance, where light itself bends, stalls, and sometimes escapes sideways in spirals of radiation. Surrounding this fiery ring is the ergosphere, a swirling storm in space where even the fabric of reality is dragged around like water circling a drain. Here, nothing can stay still. Even if you tried to hover, you'd be caught in the flow, pulled along by the black hole's spin. Space and time themselves are twisted into motion. If you could look inside, you wouldn't see a simple hole, but a churning, luminous whirlpool of cosmic fury. And then came Kerr's most shocking revelation. His math hinted at the impossible. He realized that a spinning black hole could, in theory, create a tunnel through space and time. These tunnels, called wormholes or Einstein-Rosen bridges, might link distant parts of the universe, or even different universes altogether. Fall through the blazing ring, the math suggested, and you might emerge somewhere else. Another galaxy, another era, maybe even another reality. To understand it, imagine space-time as a soft blanket stretched out before you. Two faraway cities sit at opposite ends. Walking across the surface would take years, but fold the blanket so the cities touch, then punch a hole through both layers. That's a wormhole. A shortcut. A cosmic backdoor that cheats distance itself. If Kerr's equations are right, black holes might not be tombs at all. They could be gateways, not endings but beginnings. The other side of such a portal could be a white hole, the mirror twin of a black hole, where nothing can enter, only exit. While black holes swallow everything, white holes might spit it all back out, perhaps into another universe entirely. In that upside-down cosmos, the laws of physics could reverse. Time could flow backward. Gravity might push instead of pull. It could be a world where the impossible is normal, where light falls up, where atoms dance freely, and where, as some physicists jokingly say, cats solve riddles. But of course, nature guards her secrets fiercely. The beautiful dream of crossing a wormhole is crushed by harsh reality. The same rotation that keeps a black hole open also bathes it in deadly radiation. The energy around its rim would vaporize anything that dared approach. And even if you somehow survived the trip through the fiery ring, the wormhole itself would likely collapse in an instant, sealing behind you before you could glimpse the other side. Then there's Einstein's unbreakable rule. Nothing can move faster than light. No matter how clever our shortcuts, we can't truly outpace the universe's ultimate speed limit. For now, wormholes remain a tantalizing mirage, a door drawn on the wall of reality, forever locked. And yet, the idea refuses to die. Scientists still chase it, dream it, whisper about it in late-night discussions and space agency corridors. Because even if wormholes are unstable, even if no traveler could survive the plunge, they remind us of something profound. The universe is not only stranger than we imagine, it's stranger than we can imagine. Somewhere, beyond the reach of telescopes and theory, perhaps a black hole spins not as a grave but as a gate, its ring of fire glowing against the dark, daring the curious to come closer. Because the dream, that impossible, burning dream of crossing the stars in a single heartbeat, still lives, and it burns brighter than ever. Could there be anything more shocking than the reality of the revealed black hole? What possibilities are we unprepared to come to terms with? Let's talk about that mind-blowing truth we are probably not prepared for. We might already be inside one to look beyond the edge of everything we know, the point where space and time fold into silence. We need a new kind of physics. The old rules crumble when gravity and quantum mechanics meet. Enter superstring theory, the bold, almost insane idea that could weave the universe into one story. It says that everything, stars, atoms, oceans, your heartbeat, isn't made of point-like particles at all, but of tiny vibrating strings. Each one hums its own note. Pluck one string and you get an electron. Strum another and you call forth gravity. Together, they form the ultimate symphony. The universe is not a machine. It's a cosmic orchestra playing existence into being. But every melody needs a stage wide enough for the instruments. For strings to dance, they need 10 dimensions. We only see 4: length, width, height, and time, but the rest are still there, curled up so tightly they hide from sight. They twist and loop within every point in space, smaller than atoms, smaller than imagination itself. At the birth of the universe, all 10 dimensions stretched vast and free, but as creation cooled, 6 of them folded in on themselves, retreating like shy ghosts behind the curtain of reality. What's left is the stage we call the universe, where the visible 4 dimensions perform their eternal act. Now comes the breathtaking twist, one offered by the visionary physicist Michio Kaku. What if our entire universe lives inside a black hole? Think about it. The invisible boundary that no light can escape from, the event horizon, might not just be the prison wall of matter. It could be the womb of worlds. The Big Bang, in this view, was not an explosion from nothing but a birth, a moment when a black hole in another universe pinched space so tightly it gave rise to ours. Picture a cosmic umbilical cord, a wormhole, through which energy, time, and laws of physics flowed into this new realm. Every black hole we peer at in the night sky could be nurturing a baby universe, quietly expanding on the other side. We, then, are like goldfish in a cosmic bowl, swimming in circles, mistaking the glass for the whole ocean. We see ripples, gravity waves, cosmic background noise, but what we sense are only faint vibrations from dimensions we can't perceive. We're surrounded by clues that whisper, "There is more." When astronomers captured the first image of the black hole in galaxy M87, humanity stared into the dark heart of infinity. But perhaps we weren't just looking at a black hole, we were looking into a mirror. Maybe that blazing ring of fire was showing us our own cosmic cradle, the shadow of the place we came from. So now the question lingers like a haunting refrain. If our universe truly began inside the belly of a black hole, if we are already adrift within its endless night, then where does the next tunnel lead? What waits beyond the next horizon, where even light surrenders and only mystery remains? We would love to hear your thoughts in the comments below. Don't forget to like and subscribe.